Factoring quadratic trinomials. To factor quadratic trinomials, we will need to turn it into 4 terms so that we can factor by grouping. I'm going to teach you 2 methods to do this. In both methods, we begin by multiplying the leading coefficient by the constant, in this case 6 times 7 for 42. We need 2 factors of 42 that will add to the middle term, 17. So we find all the factors of 42. Look through the list, find the pair that adds to 17. 3 plus 14 is 17, 3 times 14 is 42. Divide the middle term into 2 terms. Now that I have 4 terms, I can factor by grouping. Factor out the 3x times 2x plus 1. Repeat the 2x plus 1. Factor out the greatest common factor, which is 7. Now the answer will be 2x plus 1 times 3x plus 7. To check this answer, multiply it out. It should multiply back to the original. 2x times 3x is 6x squared. 2x times 7 is 14x. 1 times 3x is 3x. 1 times 7 is 7. The middle terms add it up to this term, thus we have succeeded. That was method 1. If you preferred the grid when multiplying, you may also prefer the grid for factoring. To factor using the grid, take the first term and put it in the upper left corner. Take the last term and put it in the bottom right corner. Now do the same steps for finding these 2 terms. Multiply at 6 times 7 for 42. Find all the factors of 42. When you have a pair that adds to 17, fill those in to these 2 boxes. It doesn't matter the order. Now you look for the greatest common factor of each row and of each column. Of the rows, there is a common x, and the greatest common factor is 2. Of this row, it is 1. Of the column, the greatest common factor of the numbers is 3, and the common variable is x. In this column, the greatest common factor is 7, and there is no common variable. We now have the answer written on the outside of the boxes. 2x plus 1 times 3x plus 7. To check by multiplying, all we need to do is multiply using the grid. 2 different methods is the same answer. Now let's try another example. In this example, the first coefficient is 1 and the constant is 21. 1 times 21 is 21. The factors are 1 and 21 and 3 and 7. We need a pair that adds to the middle term, which is negative 10. So we think to ourselves, how can we have it add to a negative? Well, if both factors are negative, it will still multiply to a positive, but add to a negative. Negative 3 plus negative 7 is negative 10. Negative 3 times negative 7 is positive 21. Now we follow our procedure again. Factor out the greatest common factor. Our answer is x minus 3 times x minus 7. Check by multiplying. X times x is x squared. X times negative 7 is negative 7x. Negative 3x is here. Negative 3 times negative 7 is positive 21. To use the grid method, write the first term in the top left square. Write the last term in the bottom right square. Use the same method to find these 2 terms. Now, the greatest common factor in the top row is x. The greatest common factor in the bottom row has to be negative because the first term is negative, and it's negative 3. In the column, the greatest common factor is x. In this column, the first term is negative, so the greatest common factor will be negative, and is negative 7. So the answer is x minus 3 times x minus 7. The same answer a new method. Now, pause the video now and try this example yourself. Now that you've tried it yourself, check your work. Notice that our coefficient times our constant multiplies to a negative, so one of the factors will need to be negative. We look over here and see that we need to add to a positive, which means the smaller factor will need to be negative. Negative 3 times 5 multiplies to negative 15. Negative 3 plus 5 adds to 2x. So this is our choice. X squared minus 3x plus 5x minus 15. Factor by grouping. And our answer is x minus 3 times x plus 5. If we use the boxes, the first term goes in the upper left column, the last term goes in the bottom right column. The two terms we determined here go in the other two boxes. This row has a greatest common factor of x. This row has a leading coefficient of negative 3, so the factor is negative, and it is 3. In this column, the greatest common factor is x. In this column, the greatest common factor is 5. X minus 3 times x plus 5. These two answers were achieved different ways, but both are correct. Pause the video now and try this one yourself. Remember that your factors will have to multiply to a negative 70 and add to a negative 9. Now that you've tried this one yourself, watch and check your work. First I list the factors of 70. Then I check. I need to add to a negative and multiply to a negative. So one factor needs to be negative. And since it needs to add to a negative, the larger factor needs to be negative. Checking through my list, 5 plus negative 14 adds to negative 9. Factor by grouping. The answer is 2x plus 1 times 5x minus 7. Remember to check by multiplying. The grid method would put a 10x squared in the upper left corner, negative 7 in the bottom. Use the same method to find your other two terms, which are 5x and negative 14x. The greatest common factor here is 2x. Greatest common factor here is 1. In this column, the greatest common factor is 5x. In this column, the first factor is negative, so the greatest common factor will be negative, and it's a negative 7. So once again, 2x plus 1 times 5x minus 7. In this case, checking by multiplying is easy since the grid is already laid out. In the next example, you will need to multiply to a positive and add to a negative. Pause the video here and try it yourself. Now that you've tried it yourself, watch and check your work. The two factors multiplied to 168. Since they multiply to a positive and add to a negative, both sets of factors need to be negative. Negative times a negative is positive, negative plus a negative is negative. Looking through our list, we find that negative 8 plus negative 21 equals negative 29. This is the correct answer. Using the grid, once again, 7x minus 4 times 2x minus 3. In this example, it looks as if we will have to multiply and get a very large number like we did in some of the other examples. But it's a good idea to look for a greatest common factor first. Notice that every one of these terms is divisible by 3. So let's pull out the greatest common factor before we begin. Negative 3 times x squared minus 3x minus 10. Remember, whenever you pull out a greatest common factor, if the leading coefficient is negative, the greatest common factor is negative. Now this is a much easier case. We need to remember that our answer will have a negative 3 in the beginning, but we only need to multiply 1 times negative 10. This needs to add to a negative 3 in the middle, so we'll put a negative next to the larger factors. 2 times negative 5 is negative 10. 2 plus negative 5 is negative 3. And write out 4 factors: x squared plus 2x minus 5x minus 10. Factor by grouping. The answer is negative 3 times x plus 2 times x minus 5. This is called factoring completely. You want to make sure that you pull out a greatest common factor first and then factor. If we do this with the grid, we also need to have already pulled out the greatest common factor before we do the grid. So pull out the greatest common factor and write it at the beginning of your answer. So our factors are x plus 2 and x minus 5. Once again, the same answer, 2 different methods. In either case, to check by multiplying, first multiply the 2 binomials, take that answer, and multiply it out by the greatest common factor, and you'll get back the original trinomial. Now pause the video and try this last example yourself. Remember to look for a greatest common factor first. Now that you have tried it yourself, check your work. So our answer is 2 times 5x minus 3 times x plus 2. Even if you use the grid, you need to factor out the greatest common factor first and write it outside. So we get the same answer, 5x minus 3 times x plus 2. Always remember to include the greatest common factor we pulled out in the beginning. This is called factoring completely. You've now seen several examples of how to factor quadratic trinomials. Use these notes while completing your homework. Thank you.